Right, weekly paper number 4. Weekly paper number 4. Right. The first question says, one end of a uniform rod of length 2L is in contact with the inner surface of a fixed smooth ball of radius simple A. Here is then L, whose circular edge is horizontal and uppermost. The rod is in equilibrium. A point on the rod in contact with the circular edge and a portion of the rod projecting beyond the circular edge. The angle the rod makes with the horizontal is theta, so that 2a cos 2 theta is equal to L cos theta. Hence, deduce that cos theta this. Shows that the length of the rod projecting beyond the rim is this much. Okay. Now, we'll draw the diagram there. You see, complete circle I draw. Right. Now, I take this way, the lower half. Right. Draw this resting like this. This rod. Okay. Now the reactions we can mark. Here the reaction is perpendicular to the rod. Here reaction passing through the center of the ball. Therefore, they must meet at a point on the circumference, right? We know that in theory we did, right? This way. Right? This way. We have that. Here the normal reaction should pass through this point. Perpendicular. Okay, let us take this as R and this is S. So the next force acting on the rod is its weight. So therefore, finally the rod is in equilibrium under the action of free forces. Therefore, the line of action of weight produced should pass through the point of intersection of these two forces, right? So I draw it like this. This should be there for the center of gravity, right? Okay. We are given the rod is uniform rod of length L, no? 2L, the length. Okay. Now I make a construction like this. I draw a horizontal line through this point. Definitely, when we draw this circle accurately, the horizontal line draw here definitely passes through this point here, right? This point. the reason we can say here, right? This is what? A diameter. From this end of the diameter, we draw vertical line. From this end of diameter, we draw horizontal line. The angle between vertical line and the horizontal line is 90. Right. So therefore, the angle between this line and this line is 90 here. But these two lines are coming from the two ends of a diameter of a circle. You know, in a circle, when we join the two ends of a diameter to point on the same circumference, the angle between the two lines is 90. Because of that, the two lines, this and this, must meet here, right, on the circumference. Right. Now, the length from here to here, L, because the length of the rod given as 2L, right? I can take, this is L, this is also therefore L. And also, the radius is say diameter 2A. And we are given, next one, the angle the rod makes with the horizontal is theta. If the angle rod makes with the horizontal is theta, this is theta. Because this line is horizontal line, this is also horizontal line, right? So therefore, if this is theta, this is also theta. And also from here to here, the radius. From here to here, the radius. Therefore, these two sides of the triangle equal means this angle and this angle equal. Therefore, since this is theta, this is also theta. Then we can write this length here. This length you can write in two ways. This length you can write in two ways. First way is what? From here to here, L, this is theta, therefore this is L cos theta. Equals, the same length we can write here, the same length, this is now 2 theta, from here to here, 2A. 2A, this is 2 theta, 2A cos 2 theta. So therefore, by geometry, we get the answer very easily like that, okay? Right. Okay, and then draw the diagram and write by the geometry this way the answer, right? Therefore, we have 2A cos 2 theta is equal to L cos theta. Right, this way we took the answer. Now, I can write this cos 2 theta as 2 cos square theta minus 1 equals L cos theta. Then remove the record. 4A cos square theta, bring this side, L cos theta minus 2A equals 0. Then, this is the quadratic equation in people. Cos theta will apply quadratic formula. Cos theta is equal to minus B. B is minus L minus B plus or minus square root of B squared minus L squared. B squared is then L squared. B squared minus 4 times A, 4A. C is minus 2A. Divided by 2, A is 4A. This way we get. Then we can simplify this. Cos theta. L plus or minus. Here L squared minus minus plus 1632 A squared over the people 8A. Right. Now theta is acute angle, well obvious. Theta is acute angle, well obvious. When theta is acute angle, cos theta should be positive. So therefore, if I select a minus sign, since this answer greater than L, L minus greater than L will give to the numerator negative, giving cos theta negative. Cos theta can't be negative because theta is acute. For acute angle, cos is positive. Right? So therefore, we select plus sign. Right? Cos theta greater than 0. Therefore, we can select the answer for cos theta. L plus square root of L squared plus 32 A squared over 8A. This way we get. Right. What is next one asking? Shows that the length of the rod projecting beyond the rim is this much. This one asking to take. All right. If I take it as x, right, the whole length is what, people? Whole length is 2L. Whole length is 2L. I am going to subtract this portion from here to here. This length from here to here, the length I can find. What is that? 2A here 90. This is theta. Therefore, this length from here to here, 2A cos theta. From the whole 2L length, I subtract 2A cos theta. Then we get x. Then we get x equals 2L minus 2A cos theta. People, cos theta is this now. Then we can put that there. Then you get the next answer, right? I can write it like this. X equals 2L minus 2A cos theta. Open the bracket, L plus square root of L squared plus 32A squared divided by 8A. This and this you can cancel down. This and this you can cancel down. Here we get 4. Then we can write, take in the common limit as 4. Right? Then this 4 comes here and 8 will come in minus square root inside the root sign we have L plus inside the bracket L plus square root L squared plus we get. Now we can simplify this. Here remove the bracket, right? 8L minus L, 7L plus and minus minus, then we get the answer, no? Then that answer is coming how? L minus L is 7L minus square root of L squared plus 32 A squared upon 4 is the length of the rod projecting beyond the rim. Right. This is how we take that first answer. Okay, the second question, vector question. Okay, in the trapezium ABCD, AB vector simple B and AD vector simple D. DC is 1/3 AB. The point E is on BC such that BE 1/2 BC. Show that AE is answer. The point of intersection X of the lines AC and DE is such that AX lambda AC dx equals mu DE, where lambda and mu are two constants such that lambda between 0 and 1 and mu between 0 and 1. So that AX this and AX this, hence find the values of lambda and mu. deduce that Ax vector is this, right? Okay, we'll do the diagram there. Trapezium here, the DC here, AB here. Here A, B, C, D. A D vector given as simple D, A B vector given as simple B, and D C vector given as B by 3, vector B by 3, right? And E is here, right? AE joined, DE joined like this, right? And AC. AX. Okay. We are given the DC vector B by 3 and BE vector 2/3 BC. BE vector 2/3 BC, right? Okay. Now, first one asking for this AX lambda AC dx mu DE given. AX vector given as lambda AC and dx vector given as mu DE. Mu DE, right? Now, this is a diagram. Okay. First one, by ABE triangle, we can write AE, right? By ABE triangle, you can write AE vector, right? AE vector you can write as AB plus BE, AB plus BE. AB plus BE by the triangle of vector addition. But we are given BE 2/3 BC. Then for this BE I can write 2/3, right? 2/3 BC. Now BC, yeah, BC vector we can write how? B A plus A D plus D C. That way we can write, huh? Okay. Right. Then AB vector, yeah, minus B. AB vector is B, BA is minus B, yeah. Then I can write AE. AB is vector B, 2/3 BC vector only. Now I am going to write BC vector here, B2. C vector BA plus AD plus DC, right? BA is minus B. AD is simple D and plus B by 3. Okay. Now we can simplify that. AE. Okay. Take the here simplification as common denominator 3. Right. Then we get 3B to the bracket minus 2B plus 2D 2b by 3. Since here we have taken this common denominator, outside of this we should have 1/3. Then here we get 3b minus 2b is b. Here 3, 5b by 9 coming, and 2/3 d, yes. 5 by 9d plus 2/3 d. 2/3 d is our AE vector. Okay. Secondly, A vector answer we got. The point of intersection x is the right. Now, asking AX lambda AC. Right. AX we can write now. AX vector lambda A C, AX vector lambda AC vector we can write AC vector, no? AC vector you can write AD plus DC, it is D plus B by 3. AD vector plus DC vector AX vector is equal to lambda times AD vector simple D, DC vector simple B by 3. Okay, that we got. Now, next one, AX vector is asked in another way. For that, we can take this way. Since we have given this dx vector as mu times dE, I can write, yes, dx vector I can write. First I am going to write dx vector this. Dx vector is equal to mu times dE. That way we are given dx vector mu times dE vector. Right. We need to find dE vector, that we can write dA plus AE. dA plus AE. dA minus D vector AE is this. Right. Now dx vector we found. Now we need people AX vector. Right. Now AX vector you can write. Right here. AX vector you can write AD plus dx. AD plus dx. AD vector plus dx vector. AX vector is therefore equal to AD simple D, dx vector mu times this, mu times dA vector plus AE vector. Right? Okay. dA vector minus D mu times dA vector minus D, AE vector this now 5 by 9D 5 by 9 times simple D vector plus 2D by 3, 2/3 D. Then when we simplify this, yes, we can furthermore simplify this. AX vector right here we get made a mistake. I think AD vector is D, dx vector D A plus A E. Here 5 by 9D. Yes, this is a mistake I have made. AE vector we got 5 by 9B. Here B, not D. Here we have B. 5 by 9B. Right. So then here we must write AE vector 5 by 9B. Correct, no? Okay, now once I simplify that, we get, right, B and D we can take separately. Yes. B vector I can first write like this. AX vector is then mu into this, no? 5 mu by 9, right? 5 mu by 9B. We get like that. Next one, when we take D, here we get people 2/3 D minus D. Minus 1/3 D must be multiplied by mu. And take this D out. When you take D out, 1 here minus 1/3. That means mu. Mu divided by 3 times vector D. Right. Only the simplification here I did here. Right. This way we get that. 5 mu by 9B plus 1 minus mu by 3. Right. So here the answer 3B minus 2B should be B. I wrote that as earlier D and B, and here 2B by 3. Then we get okay, correct, no? 5B by 9 coming. That's correct. Now there are two answers for AX. One is this. Other one is this. The same AX vector we found in two ways. Therefore, the right hand side we can equate. Right? When we equate right hand side, what do you get? We get right here. Equating AX vectors. Once we equate AX vectors, here we have lambda times vector D plus vector B by 3 is equal to this one, equal to this 5 mu by 9B 1 minus mu by 3 D. 1 minus mu by 3 times D. Now, in the left and right, you can equate the coefficients of B and D vectors. When I equate the coefficients of B, lambda by 3, right hand side, 5B mu by 9. Here you can cancel down. We get lambda 5 mu by 3. First relation. D coefficients when we equate lambda here right hand side this 1 minus mu by 3. Okay. Then here we can solve. Right, I can put this lambda where here 5 mu by 3, 1 minus mu by 3. Bring this side, then we get 6 mu by 3. That is 2 mu 1, mu equals half. Correct, no? Mu equals half. When mu is half, lambda we can write 5 by 3, mu is half. Then we get lambda 5 over 6. Lambda 5 over 6. Now finally asking what is AX. AX can be found substituting here for this lambda. Okay. Now AX you can write. Therefore, x lambda is 506 d plus b by 3 5 d vector over 6 plus 5 over 18b. Right, that's how we take that answer. Right, the next question, number 3. Take number 3. Third question is this. Let A, B, C real numbers, A not equal to 0. Write down the conditions required for the roots of the equation ax squared plus bx plus c equals 0 are real and positive. Are real and positive. Right, no? Right. Ax squared plus bx plus c equals 0. Right. Real and positive, yes. Right, I am going to take this equation has the roots ax squared plus bx plus c is equal to 0. Let us take the roots of this equation as gamma delta. Right, you know, in a quadratic equation, the roots to be, for the roots to be real, its discriminant should be greater than or equal to 0. Right. And we know sum of the roots and product of the roots here we can write. Sum of the roots should be minus b by a. Product of the roots c by a. Right, then first thing, for real roots, what can say? Delta greater than or equal to 0. Delta means b squared minus 4ac should be greater than or equal to 0. Therefore, b squared minus 4ac should be greater than or equal to 0 for the roots to be real. Not only that, asking the condition required for the both roots to be positive. Right? You know, both roots positive means gamma positive, delta positive. If gamma and delta both positive, this is positive means this answer is positive. Right? Then you can write if gamma positive, delta positive, gamma plus delta positive. But gamma plus delta is what? Minus b by a. Minus b by a positive. That means people multiplying both sides by minus sign, we get what? B upon a less than 0. B upon a, when we divide b by a, the answer should be negative. Right? So, the answer of b upon a to be negative, b and a should be in different signs. That means when b is positive, a should be negative. A is positive, b should be negative. Therefore, here, first condition is this. This says what? A and b must take different signs. Different signs. Right. And also, gamma positive, delta positive means gamma delta product also positive. Gamma delta product. Gamma delta means C upon A. C upon A should be positive. That means C and A should take what? Same signs. Both negative or both positive. This says C and A should take same sign. Same sign. Right. These are therefore the conditions. Then conditions I can write. B squared minus 4AC should be greater than or equal to 0. First condition for the roots to be real. And B upon A negative. B upon A negative and C upon A positive. These are the conditions required for the roots of that given equation to be real and positive. To be real and positive. Right? Okay. That part is okay. Next one. If the above conditions are satisfied, that means these three conditions are satisfied. What is asked next? Show that the roots of the equation this are also real and positive. We'll see. Okay. The next equation given this way. A squared x squared A squared x squared plus 8 times 3b minus 2c times 6, 3b minus 2c times 6 plus 2b minus c, 2b minus c, b minus c plus ac equals 0. Right? A squared x squared plus 8 times 3b minus 2cx plus 2b minus c into b minus c plus ac equals 0. Right. We have to show the roots of this equation are real and positive. Right. I'm going to assume the roots of this equation to be alpha beta. The roots of this I'm going to assume as alpha beta. Right. Then the discriminant of this we'll see. The discriminant of this we have to simplify. Delta of this quadratic equation, b is this, a times 3b minus 2c, b squared minus 4 times a x squared coefficient, it is a squared. It means the term independent of what? X. Therefore, this whole term, 2b minus c, b minus c plus ac. This is the delta. Right. Now we have to simplify this. Right. Then when I simplify this, right, people here we have, when you square this, we get a squared. Here also we have a squared. First of all, I take that a squared out. Then I have to square this, right? A squared, then square of this, no. Let us take the square of this, 9 b squared minus, multiply this 2 and again multiply by 2, 12 bc, right? And plus 4c squared. And here minus 4 we have, but the a squared we took out. Inside the bracket, remove here 2b squared, 2b c minus bc minus c minus b, c plus c squared plus ac. This way, right? Right, here minus 8b squared, here 9b squared. We get b squared. Right. And next one, here we get 4c squared, here minus 4c squared. These two we can cancel down. Here, minus 2bc, minus bc, minus 3bc. Here minus 4, minus 3bc. Minus 4 means plus 12bc. Here minus 12bc. That also we can cancel down. Then here we get minus 4 and AC, minus 4 AC. You can see this b squared, a squared, a not equal to 0, no? Then a squared is positive. B squared minus 4ac here greater than or equal to 0, because we are going to show the roots of this real and positive when these conditions are satisfied. Therefore, b squared minus 4ac here condition is greater than or equal to 0, no? Therefore, this is greater than or equal to 0. And then what can say? Therefore, delta greater than or equal to 0. Then what can say? Then the roots of this equation real. Roots are real. Roots are real. Next one. We need to show the roots are positive. Roots are positive can be shown this way. I am going to write first alpha plus beta. To show this both alpha and beta are positive, we have to first show alpha plus beta positive, and secondly alpha beta product also positive. Then only alpha beta both become positive, right? Alpha plus beta we can write here. Look at this, minus b. B means this part. 8 times 3b minus 2c minus b upon a. X squared coefficient, it is a squared. 1 a we can cancel down here. Alpha plus beta, right? Then we can write, remove the bracket here, minus 3b over a minus minus plus 2c over a. You know, people, b upon a here negative. That this is negative, b over a negative, and here negative. This is positive. C over a here positive. Therefore, this right hand side positive. Therefore, alpha plus beta is positive. Right. By this sum alpha and beta sum positive, by that only we can't say alpha beta both positive, right? In addition to this, we have to prove alpha beta product also positive, right? Alpha beta product now we can write. This is C. C divided by X squared coefficient. It is 2b minus C, b minus C plus AC divided by A square. Right? Is the alpha beta product. Right. Now we have to simplify this also. Yeah. Then we can write alpha beta product. I take this A squared at the denominator. Close the bracket here. Yeah, 2b 2b squared minus 2bc minus bc plus c squared plus ac. Right. Now I can write this alpha beta product, multiply this and this, then I can write that 2 times b squared over a squared, b over a perfect square. Here, minus 3bc, no? Minus 3bc. Minus 3bc. Should be divided by a squared. That a squared I write here, a and here a. And I take it like this. C squared over a squared, this and this, C upon a, perfect square. And AC divided by a squared means C upon a. This C I can simplify. Okay. You can see, people, this is since perfect square positive. Right. Here, B over A. B over A negative. Look at this. Negative. C over A positive. Here, look at this. Right. Then here negative, here positive. Therefore, with the minus sign, this whole term is positive. Right. Here C over A perfect squared, since this is a perfect squared, positive. C over A over there positive. This is positive. Then, people, you can see the right hand side is clearly positive. Therefore, alpha beta product also positive. Right? Therefore, alpha beta product positive. Now, sum of alpha beta positive, product of alpha beta positive. There are two numbers, there are sum positive, product also positive. Then the two numbers, each should be positive. Therefore, we can write hence. Hence, alpha positive and beta positive. All right. Then the roots are what? Real of this equation and each positive, right? Positive. Right. Now, next one asking the last question. If the roots of this equation are alpha and beta, by using a suitable transformation, find the quadratic equation with the roots 2 upon alpha and 2 upon beta. Yeah, that can easily be done like this. Yes. Now, I'm going to assume, the roots are given, no? Roots are alpha, beta, no? Yes, I'm going to take the two roots you can see there, asking, the two roots asking 2 over alpha is one root, the other root is 2 over beta, right? Asking the roots, the equation with the roots, one is 2 over alpha, other one is 2 over beta. So these two roots you can see symmetric. Then we take one root as y. Let y equals 2 upon alpha. Then subject alpha by this 2 upon y. Right? If I take this equation, its one root is alpha, other one is beta. Since alpha is the root of this, the alpha should satisfy this equation. Alpha should satisfy this equation. Okay? Right. Then we can write, since alpha is a root of given equation, what can you say, people? Alpha then should satisfy this equation. How? A squared alpha squared plus a times 3b minus 2c alpha 2b minus c b minus c ac should be equal to 0. Then for this alpha we put what? 2 upon y. Then here we get a squared 4 over y squared plus a times 3b minus 2c alpha 2 upon y plus 2b minus c b minus c ac equals 0. Now we need to take the quadratic equation in y. So then we multiply by this y squared. Then this should be multiplied by y squared. Then we get 2b minus c b minus c plus ac into y squared. And this should be multiplied by y. Then we get 2 times a 3b minus 2c y. and this is 4a squared. 4a squared equals 0, right? So this is the required quadratic equation, right? With the roots 2 upon alpha and 2 upon beta. Then it is not in terms of x, in terms of y. So it's all right, people, because the quadratic equation, when we write, it is not compulsory to use always the variable as x. Any variable we can use. So therefore, we can keep the required quadratic equation like this. If you want to keep that in terms of x, then replace this y later only, y later by x. That's all. Okay, I think that is the end of that question. Right? Okay. Right.